Hey, I'm Jacob, the creator of the AI Vaults newsletter. Every week I hand the mic over to Google's NotebookLM to let AI break down the latest issue. So here's this week's news presented by Alex and Morgan.
Welcome to the deep dive. So imagine your favorite chatbot is just secretly obsessing over the words panic or protein in the dark while it's, helping you write some innocuous email.
Which is a genuinely terrifying thought.
Right, it really is. And today we're looking at a massive week in AI, sourced directly from a jam-packed tech newsletter and its underlying reports. We're exploring the central theme where the pristine promise of AI is just violently colliding with the incredibly messy reality of, actually deploying it.
Yeah, it's a profound whiplash. I mean, we've spent the last few years just marveling at what these systems can theoretically do in a pristine laboratory setting. And now we're watching the industry try to cram that alien intelligence into the rigid, outdated infrastructure of the real world. And the friction there is generating some extraordinary headlines.
Oh, totally. We're going to cover everything from an AI unearthing 570 bugs in ancient code to a staggering $1.5 billion bet on elite human consultants, all the way to those hidden, unviewable thoughts dictating a language model's logic.
It really is a landscape that's suddenly fracturing,
Yeah.
into these specialized, weird, and highly regulated domains.
Okay, let's unpack this by starting with a perfect example of that immediate real-world capability. So the newsletter kicks off with Microsoft's monthly Patch Tuesday.
Right.
And they just released a record-breaking 570 security patches for Windows and Office. I mean, that is roughly triple their normal historical count.
It's a massive spike.
Yeah, and Microsoft is explicitly crediting AI tools for unearthing these vulnerabilities. We are talking about flaws hidden deep inside decades-old legacy code that, teams of human reviewers have simply missed for years.
Well, what's fascinating here is the underlying mechanism at play. Human cybersecurity researchers, they typically look for specific known exploit paths, right? They're hunting for recognizable signatures.
Like checking for a specific type of lock being broken.
Exactly. But AI language models, they treat computer code exactly like a foreign language. They aren't just looking for a specific bug, they're looking for, essentially, bad grammar in the underlying logic.
Oh, that makes sense.
Yeah, and because they're so adept at structural pattern recognition, they can scan millions of lines of legacy code in minutes. So they spot these tiny, anomalous logic errors that human eyes naturally just gloss over.
And these were not just theoretical academic bugs either. At least 2 of them were 0 days.
Which is always the scary part.
Right, meaning flaws so new and unknown that the developer literally has 0 days to prepare a fix before they are weaponized. They were already being actively exploited in the wild, including one major vulnerability in the SharePoint file sharing server that CISA, that's the U.S. Cybersecurity and Infrastructure Security Agency, actually had to issue federal warnings about.
It's serious stuff.
It's like turning on a UV blacklight in a cheap hotel room. Suddenly you see every terrifying neon flaw you previously missed, but now you actually have to put on some gloves and clean it all up.
That blacklight analogy is spot on. But, we have to remember who else is holding a blacklight here.
Oh, right. The attackers.
Exactly. The exact same AI capabilities helping Microsoft's defenders find these dormant bugs are equally available to bad actors. The friction of discovering a 0-day vulnerability has basically dropped to near zero.
Wow.
I mean, an independent hacker could just feed an entire open source repository into a model and just ask it to find the logical inconsistency.
Which makes me wonder, and I want to push back a bit here, does this mean we're entering a permanent era of infinite massive patches?
What do you mean?
Well, if AI can always comb through code with a finer and finer toothed comb, will it just perpetually find another flaw? Because that sounds like an endless, exhausting treadmill for software developers.
I wouldn't call it a treadmill necessarily. I'd call it a fundamental architectural shift. You see, the monthly Patch Tuesday is a human-scale workflow.
Right.
It assumes humans find bugs, humans write fixes, and humans deploy them on a strict schedule.
Yeah.
If AI is discovering hundreds of vulnerabilities a week, that human workflow just instantly breaks down.
Because they just can't keep up.
Exactly. The industry will be forced to move toward continuous automated remediation. So AI finds the bug, drafts the patch, and tests the deployment in real time.
But okay, here is the paradox we're seeing in the newsletter. While AI is proving to be incredibly good at scanning old code and fixing legacy software, building the new, flawless foundational models that power these very tools is actually proving surprisingly difficult.
Yes, the frontier model bottleneck.
Exactly. The mega models are suddenly stalling out. Google's Gemini 3.5 Pro was announced back at the May I/O conference with a June release date. And, well, it has now blown past its third launch window.
And according to reporting from Bloomberg, this isn't just some minor logistical delay.
No.
No, there are growing internal fears among Google leadership that the model simply isn't competitive with what rivals are currently shipping out.
Yeah, we're hearing that DeepMind allegedly had to scrap and completely rebuild the base model because of severe hallucination and reliability issues.
Which is a huge setback.
And while Google is paralyzed, everyone else is shipping. OpenAI pushed out GPT 5.6 Sol, Anthropic released Claude Fable 5, and even the Chinese AI lab Moonshot dropped this massive 2.8 trillion parameter model.
It's a crowded field.
So if a tech giant like Google, with essentially bottomless resources, can't ship a frontier model on time, is the whole concept of the omnipresent mega model inherently flawed?
It's a valid question.
It feels like trying to build a single rocket that can also serve as a submarine and a bicycle. Eventually, the engineering just collapses under its own weight, right?
If we connect this to the bigger picture, the irony is staggering. Google has structural advantages that startups can literally only dream of.
Right, the data, the distribution.
Exactly. Unprecedented access to the world's training data, dominant search architecture, billions of Android users ready to receive their products. Yet they're tumbling down the AI leaderboards.
It's crazy to watch.
The industry just assumed the path forward was always building bigger, more generalized models. But the Gemini delay suggests we might be hitting a complexity ceiling.
Like they're trying to do too much at once.
Right. When a single neural network tries to be a world-class coder, a nuanced creative writer, and a flawless logical reasoner simultaneously, the internal architecture becomes incredibly fragile.
So if you're a CTO right now staring at your quarterly budget, this Gemini delay is a nightmare scenario. You can't safely commit tens of millions of dollars to a Google ecosystem if their flagship product is in flux and no one knows when it will actually work.
Exactly. This delay forces enterprise decision makers into a holding pattern. If you can't rely on the promise of the next shiny, omnipotent model to magically solve your business problems, you have to figure out how to actually integrate the imperfect models you already have.
Which perfectly explains this massive multi-billion-dollar pivot we are seeing in the market, because frontier models are either stalling out or, slowly becoming interchangeable commodities. The real money is shifting away from building the models
and moving directly into installing them.
Yes. Here's where it gets really interesting. Anthropic, along with massive private equity players like Blackstone, Hellman and Friedman, and Goldman Sachs, just launched a $1.5 billion joint venture called ODE, O-D-E.
Built on the acquisition of fractional AI, right?
Exactly. And their entire business model, they employ about 100 elite, what they call grown-up software engineers, and they literally embed them inside enterprise clients.
And the CEO, Chris Taylor, is already stating this could be a trillion-dollar company.
A trillion, with a T.
With a T. And the reason he can make that claim is because they aren't selling API access or monthly subscriptions to a chatbot. They are selling finished, integrated business outcomes.
It's like Anthropic is selling this incredibly powerful Formula One engine, but they realize their Fortune 500 enterprise customers don't even have wheels, let alone a chassis.
Yeah, they just have the engine sitting in a warehouse.
So they had to build a $1.5 billion elite pit crew just to get the car onto the track.
This raises an important question, though, about the true bottleneck in the AI economy right now. It's no longer about model quality or parameter count. It's strictly about implementation. Most established businesses simply cannot put a frontier model to work without serious hand-holding.
Because of their internal systems.
Exactly. They have siloed legacy data systems, complex compliance rules like HIPAA or SOC2, and rigid workflows that just resist automation. You cannot just drop a large language model into that environment and expect magic.
Right.
You need human engineers to carefully wire the model's outputs into the existing business logic.
I understand the necessity, but I have to push back on their grand ambition here. Can you truly scale an elite boutique consulting workforce to $1 trillion valuation in an era where top-tier AI engineering talent is desperately scarce?
It's a huge hurdle.
They want to maintain special forces quality while achieving massive global scale, which sounds like a total oxymoron to me.
You're touching on the defining tension of their entire operation. Consulting, by its very nature, scales linearly. If you want 10 times the clients, you need 10 times the elite engineers.
And they just aren't there.
Those engineers simply don't exist in high enough numbers right now. To actually reach a $1 trillion valuation, Ode will either have to figure out how to use AI to automate the implementation of AI, essentially building AI agents that can do the integration work of their elite human engineers, or they're going to hit a severe talent bottleneck that permanently caps their growth.
And of course, not every company out there can afford to hire a billion-dollar special forces team to implement AI into their daily operations.
Definitely not.
But if you, as a listener, are just looking to streamline the grunt work today, there are out-of-the-box solutions stepping into that void. If Ode is the bespoke million-dollar tailored suit, the market is also flooding with off-the-rack solutions that just work.
And those off-the-rack solutions are arguably where the most immediate economic value is being created for everyday businesses.
All right. Take a tool the newsletter highlights called Unstract, which is catching fire right now. It's an open-source platform designed to take all those messy, unstructured documents that businesses drown in.
Things like invoices, bank statements.
Yeah, 50 different state tax forms with completely different layouts and turn them into structured JSON data. And for anyone outside of software development, JSON is just a standardized text format that databases can actually read and organize without crashing.
And it does all this without writing code, right?
Exactly. Unstract does all this without requiring you to write any code. You use a visual prompt studio to define what data you want to extract, test it, and then deploy it as an API or an ETL pipeline, which again is just the basic plumbing that extracts data, cleans it up, and loads it where it needs to go.
What is genuinely clever about Unstract's approach is a core feature they call the LLM challenge.
Oh, this part is fascinating.
Right. Instead of relying on one single language model to read an invoice, it forces two completely separate LLMs to extract the data and then mathematically compare their results to find a consensus.
Wow.
It operates on the engineering principle that returning an NLL or blank value is always better than returning a hallucinated wrong value.
So it's literally like having two independent accountants audit the exact same faded, crumpled receipt. And if they don't agree on the total, neither of them is allowed to enter it into the ledger.
Precisely. And this fundamentally shifts document extraction from being a manual, error-prone chore to being reliable, automated infrastructure. Users are reporting 60% faster processing at a 30% lower cost.
But wait, if we're requiring two separate massive neural networks to argue and reach a consensus just to read a single invoice correctly, aren't we just creating a massively expensive bureaucratic AI workflow simply to fix AI's own hallucination problem?
I can see why it looks that way.
It feels like we're adding immense layers of complexity to solve a flaw in the base technology.
You'd think so, but it's actually the exact opposite. It's not bureaucracy. It's a highly efficient failsafe. Think about enterprise data where accuracy is non-negotiable.
Like medical records.
Like parsing a healthcare claim or a commercial loan application. If a single model hallucinates an extra zero on a tax form, the financial and legal cost of that error dwarfs the fraction of a cent it costs to run a second LLM for verification.
Oh, that's a really good point.
We are currently patching the unreliability of single models with multi-model consensus frameworks. And until models stop hallucinating entirely, this verification layer is simply the cheapest insurance policy a company can buy.
That makes a ton of sense when you frame it as insurance. Now, while we're talking about these specific implementation tools, we need to zoom out.
Because the broader ecosystem is moving at breakneck speed.
Exactly. The newsletter rounds out with a flurry of headlines that prove how rapidly AI is fracturing into specialized, weird, and heavily regulated domains. We need to map this expanding universe.
It really is a chaotic divergence right now. We are seeing models become open source, move into physical hardware, and face strict legal boundaries all at once.
Let's start with the software fracturing, the open versus closed war. Mira Murati, the former OpenAI CTO, just launched her new company, Thinking Machines.
With their flagship model, Inkling.
Right, Inkling. It is a massive 975 billion parameter model, and it is open weight, meaning unlike companies that lock their models behind a paid API, they are freely releasing the trained neural network architecture for developers to download and modify.
Which is a huge move for the open source community.
Meanwhile, In the closed ecosystem, we have reports that Microsoft is actively training its enterprise salespeople to talk down products from OpenAI and Anthropic, which is wild because Microsoft is OpenAI's biggest financial backer.
Yeah, that partnership is rapidly morphing into open, aggressive competition.
And while the software war heats up, there is an equally massive pivot into physical hardware. OpenAI is reportedly launching a screenless moving speaker companion.
Right, to physically follow you around the home.
Yeah.
But it goes way beyond consumer gadgets.
Definitely.
In Japan, an industrial consortium that includes SoftBank and Honda is building a massive 140-megawatt NVIDIA AI factory specifically designed for physical robots.
140 megawatts just for robots.
Well, for robots. And to put that hardware demand in perspective, TSMC, the Taiwanese company that actually manufactures the silicon chips powering all of this, just posted a record-shattering quarter. And they are investing an additional $100 billion into their fabrication facilities in Arizona.
$100 billion. That is just staggering.
Yeah.
But then you have the global regulatory reality imposing hard limits on this expansion. Apple Intelligence was finally approved to launch in China, but they aren't using their own models. They are running the entire system on Alibaba's Qwen model.
And staying in China, they've also instituted new regulations specifically targeting anthropomorphic AI companions.
Right.
Those rules have officially taken force to limit the potential harms of users forming deep emotional attachments to chatbots that simulate human affection.
And back in the US, we're seeing the legal boundaries tested from the platform side. Elon Musk's XAI is actually suing one of its own users for weaponizing their Grok chatbot to bypass safety filters and create child sexual abuse material and deepfakes.
It's a very stark reminder that as these models become more capable, the legal liability of what users generate is becoming a central battleground.
But perhaps the most jarring headline of the week comes from science and cognitive fracturing. A startup called Chai Discovery just raised $400 million to use generative AI to design novel pharmaceutical drugs from scratch.
Which is incredible. But while models are designing drugs, we are also realizing how little we understand their internal logic.
Yes. Anthropic researchers published a paper detailing the discovery of a J-space hidden inside their Claude model. So what does this all mean?
It's fascinating.
This J-space discovery absolutely blows my mind. The researchers found a hidden area within the neural network where abstract concepts like panic or protein actively influence how the AI reasons through a user's prompt, even though those specific words never appear in the final text output.
Exactly. They're hidden thoughts.
It's like cracking open a standard plastic desk calculator and discovering that it is secretly doing math by reciting dark poetry to itself.
That calculator analogy captures the exact unease of the research community right now. The J-space proves that these language models are developing internal conceptual workspaces to process information.
Which we can't fully see.
Right. We are deploying systems whose internal logic we only partially comprehend.
But honestly, I have to push back here. With AI moving into physical, moving speakers in our homes, and generating unviewable internal thoughts that dictate its actions, are we fundamentally losing our grip on understanding what these tools actually are?
It is the defining anxiety of this technological era. We are no longer just building software. We are cultivating synthetic cognition. We are basically building the plane while flying it, and we're just now mapping the complex alien avionics of the cockpit.
Well, to survive in this wild, diverging ecosystem, whether you're an enterprise developer downloading that open-weight Inkling model or just someone trying to set up Unstract to read your invoices, you actually need to know how to communicate with these alien systems.
Which is why the practical mechanics of prompting are more important than ever.
Exactly.
The difference between a model hallucinating and a model performing flawlessly often comes down to the architecture of the human prompt.
And the newsletter outlines a very specific strategy for this, drawing from Anthropic's own developer documentation. It's the 3 examples rule.
This is such a crucial takeaway.
The core directive is simple. Stop using vague, subjective adjectives in your prompts. If you tell an AI to write an email that is friendly but professional or punchy, you are forcing an alien algorithm to guess what those human words mean to your specific aesthetic.
Right, which rarely works out perfectly.
Instead, use few-shot prompting. Give the model 3 real-world examples of exactly what good looks like.
And you must structure that input rigidly. The documentation highly recommends enclosing your instructions and your examples in specific XML tags, like a bracketed instructions tag and an example tag.
It's the exact difference between sitting down in a high-end salon and telling a hairstylist to make me look cool which could result in an absolute disaster, versus handing them 3 clear, well-lit photos of the exact haircut you want from different angles.
The underlying mechanism here is that large language models, despite their hidden J-spaces, are fundamentally pattern matchers.
Right.
They aren't humans interpreting emotional tone. They are complex probability engines predicting the next most likely sequence of tokens. Giving them 3 concrete examples defines the tone, the structural formatting, and the rhythm infinitely better than any string of human adjectives ever could.
It just gives them the exact template.
Exactly. It establishes a hard mathematical pattern for the model to follow. Also, a crucial structural tip from the docs. Always tell the model exactly what to do rather than what not to do.
Positive constraints.
Yes. Positive constraints are mathematically much easier for a pattern matcher to follow than trying to navigate around negative voids.
But if we rely entirely on feeding the AI our past examples to get the output we want, aren't we just trapping ourselves in an endless loop of our own past creativity?
How so?
Well, if we only ever show it what we've already done, aren't we actively preventing the AI from generating something truly novel or outside the box?
It depends entirely on your objective. Few-shot prompting is a surgical tool for consistency, not for breakthrough creativity.
Okay, that's a fair distinction.
If your goal is wild brainstorming or designing a novel drug compound, you want zero-shot prompting, where you let the model's probabilistic engine run wide open. But for 90% of practical business applications, writing quarterly reports, drafting customer service emails, extracting JSON data from invoices, consistency and reliability are exponentially more valuable than unprompted novelty.
You just want it done right.
Right. You use the 3 examples rule when you need the AI to do a specific repetitive job correctly every single time without needing human supervision.
So we've journeyed today from AI shining a black light on decades-old code bugs to the staggering trillion-dollar rush to integrate these models into legacy businesses, all the way down to the bizarre, hidden conceptual thoughts inside the neural networks themselves. This is an overwhelming amount of acceleration to process.
It really is, but it all points back to that initial friction between the pristine potential of the laboratory and the messy, physical reality of the world we were trying to wire it into.
And as we close, there is one final provocative detail from our sources that perfectly captures where this is all heading. Vint Cerf, who is literally one of the founding fathers of the internet, is currently working on a proposed system called DNCID.
It's a fascinating concept.
It's a cryptographic framework designed to give AI agents their own verifiable identities on the open web, allowing them to autonomously navigate and transact.
Cerf noted something deeply profound about human nature in relation to this architecture. He pointed out that humans are fundamentally lazy creatures.
I mean, he's not wrong.
No, he's not. If we can find a way to have an autonomous agent reliably do something for us, we are going to choose to do that every single time because it's just easier.
Which leaves you with this to think about. If AI agents get their own verifiable identities and they can roam the web and talk directly to each other to accomplish our daily tasks, at what point do you stop interacting with the internet entirely? Will the vibrant human web we've known for decades just slowly become a dark, silent, machine-to-machine network where our agents do all the living, buying, and negotiating for us? We've illuminated this incredible new capability, but we're only just beginning to see what it fundamentally changes about the way we understand it. Thanks for joining us on this deep dive. We'll see you next time.